Good afternoon to all. Mine is just overview and very basic knowledge. So this will help you to recall your forgotten knowledge and refresh. And also, I will give some basic information which will help you to absorb the subsequent speaker. They have very high knowledge, and when they speak at a very different level, so you should be in a position to grasp that. So I will speak in terms of forest genetic resources with reference to practical step for the state forest department for utilizing and developing forest genetic resources. So I have made into 4 categories. One is genetic resources. It is a very basic. Forest genetic resources, use of genetic resources, and CBD and the NAYOGA protocol. How far have we come in India? Genetic resources. What are genetic resources? Genetic resources are the heritable characteristics of the plant or animal of a real or potential benefit to people for food, agriculture, and forestry. Animal, plant, microorganisms, and inward which are used for food, agriculture, and forestry are called genetic resources. So examples, material of plant, animal, and microorganisms such as medicinal plants, agriculture crops, and animal breeds. So when you think of this thing and what type of organisms are considered as a genetic resources, whether it is a wild or it is a domestic, it is both wild and domestic are considered as the genetic resources. Type of genetic resources are, these are the following types of genetic resources. One is plant genetic resources, animal genetic resources, forest genetic resources, aquatic genetic resources. Other two are genetic resources of microorganism, invertebrate genetic resources. The theme for the genetic resources is the following two themes are. One is first related to food security and another one is the sharing of the benefits. Now, let us think forest genetic resources. Forest genetic resources is refer to the heritable material that are actual and potential economic, scientific, and social value. Genetic resources can be appear as a whole communities, population, or single individual, as well as seed, pollen, soma bank, and even the clonal fragments, DNA fragments. How forest genetic diversity differ from the forest genetic resources? Forest genetic diversity represents the sum of total genetic variability occurring within and among the tree species, whereas the genetic resource is the genetic material of actual or potential benefit to humankind. In other words, forest genetic resource form a subset of forest genetic diversity, which in turn appears as a subset of forest diversity. Key features of forest genetic resources. What are the key features? In most forest tree species are wild, managed in natural ecosystem, or at a very primitive stage of selection or dissemination compared to agricultural crops. Forest tree species are typically long-lived, highly heterozygous organisms that have developed a natural mechanism to maintain high level of interspecific variation, such as high rate of outcrossing and dispersal of pollen and seeds over a wide area. These mechanisms, combined with the native environment that are often variable in both time and space, have contributed to the evolution of the tree species into some of the most genetically variable organisms on Earth. In situ conservation, allowing dynamic maintenance of genetic diversity, and the process is the preferred approach for the forest species, while ex situ conservation is the most commonly used for domesticated plant species. Third, forest species have multiple functions in that they provide numerous products and services. About 80% of the people in the developing world use non-timber forest products for nutrition, health, and income. Qualifying the value of the benefit derived from the FGR is difficult for several reasons. Apart from the timber, most forest products are harvested for local consumption or commercialized without proper national monitoring and documentation. This is particular case with the developing countries. Fifth, the terms of their present or potential contribution to the food security and sustainable development, FGR are underutilized and are undervalued. Sixth one is the knowledge of FGR is usually scattered and held by the various institutions in the unpublished reports, meaning that in many countries access to its limited. Based on information such as country-specific checklist, species distribution map, and forest productive material catalog are lacking. 7. The number of known species, tree species exceeds 80,000, but current efforts in member countries to test and improve forest species focus approximately 450 species. And what are the threats to the genetic resources? The threats are forest genetic resource input risk regarding species, population, and genetic variability. These are both natural and human caused. Large of the forest genetics resources worldwide include habitat degradation and deforestation. Management practice may also have a negative impact on the genetic resource if fast-growing trees with a good phenotypes are selected, harvested, while slow-down trees with a poor phenotypes are left as seed trees. Replacement of native stands with the introduced tree species or genetically distinct population of a native trees can also lead to the loss of genetic diversity. Climate change is not only a considerable threat to the genetic diversity, but is also enhances the threat from the diseases, pathogens, insect attack, fire, and extreme weather. These factors are further complicated by the extensive and complex interaction taking place among these constituent factors. Which species and populations are more prone to experience the large impact of the climate change? The most vulnerable to climate change are probably species exhibiting rareness, very large generation time, phenotypic plasticity, limited phenotypic plasticity, low genotypic variation, and low dispersal abilities, as well as fragmented and disjunct species. The most vulnerable population include population at the rear edge of the species natural distribution, population with nowhere to go, and population threatened by the habitat loss and diseases. On the basis of the information and knowledge compiled by the FAO for the state of world forest genetic resources, Commission on Genetic Resources for Food and Agriculture developed the global plan of action for the conservation, sustainable use, development of forest genetic resources. This global plan of action identifies 27 strategic priorities grouped into 4 areas. First is improving the variability of and access to information on forest genetic resources, conservation of forest genetic resources, sustainable use, development and management of the forest genetic resources, policies, institution, and capacity building. Note number 3, which is sustainable use, development, and management of forest genetic resources, which is relevant to our present 5 days program. To enhance the sustainable use, development, and management of forest genetic resources, FGR as a key contribution to the environmental sustainability, food security, and poverty elevation involves developing overall strategies, applying specific methodologies, developing, applying new technologies, and coordinating national, regional, and global efforts. So, 6 strategies, priorities are identified. Number 1, develop and reinforce the national seed program to ensure the availability of genetically appropriate tree seeds in the quality and the quantity needed for the national plantation program. Promote restoration and rehabilitation of the ecosystem using the genetically appropriate material. Support climate change adaptation and migration through proper management and use of FGR. Promote appropriate use of emerging technology to support the conservation, development, and sustainable use of FGR. Develop and reinforce program on tree breeding, domestication, and bio-prospection in order to unlock the full potential of FGR. 6, strategic priority, which includes different countries also. Develop and promote networking and collaboration among the concerned countries to combat invasive species, animal, plant, and microbes, as well as diseases and pests affecting FGR. So, strategy number 1, develop and reinforce national seed program to ensure the availability genetically appropriate tree seeds in the quantities and the quality needed for the national program. So action required is promote the establishment, support to national tree seed supply system, enhance collaboration between the tree and seed centers, and develop common quality seed standards to facilitate the exchange of forest reproductive material within region and support the national afforestation program. I don't want to go the rational analysis because time is short. It is a very long also. Second one is promote restoration and rehabilitation of ecosystem using the genetically appropriate material. So action required is support and conduct research to identify key variables for choosing populations that are well matched to current and future conditions at degraded sites by developing guidelines and decision support tools for selecting appropriate genetic composition of planting material, develop and implement monitoring protocol to assess the variability and resilience of the tree population over the time and rehabilitate site. Third one, support climate change adoption and mitigation through the proper management and use of FGR. Action required is develop subnational, national, regional standard method and guidelines for the identification, selection, use of the species population, conservation units based on the environmental and socio-cultural factors which are human determinant of the status of the forestry and agroforestry ecosystem diversity. Assist countries or state in there to improve the conservation and the sustainable use of FGR in the face of climate change by promoting the best practices of FGR management, especially in the field of conservation, exploration, testing, breeding, and sustainable use. Promoting FGR contribution to the environment sustainability through the development and use of well-suited genetic material. Fourth, promote appropriate use of emerging technology to support the conservation, development, sustainable use of FGR. Action, the use of emerging technology support the conservation suitable use of FGR as well as tree improvement program and to enhance the use of quality FGR in the forestry program by assess available technology and the effectiveness for use in the in situ and ex situ conservation in the development of the genetic resources or priority species. New technology as appropriate such as genomic and micro-propagation can help accelerated selection process and unlock the huge potential of the forestry species. Fifth, develop and reinforce programs on tree breeding, domestication, and bio-prospection in order to unlock the full potential of FGR. Assess and evaluate the contribution of the forest species to environmental services, soil and water conservation, carbon sequestration, etc. Assess and evaluate the contribution of the priority species to important national production sector, timber, food, fodder, vegetable, oil, vegetable, medicine, etc. Develop program-based multi-purpose tree breeding for priority species. Promote participatory approach by involving local communities in selection and breeding program for priority species based on farmers' desired traits. Sixth, which involves different nations to coordinate, develop and promote networking and collaboration among the concerned countries to combat invasive species, animals, plants, and microorganisms, as well as diseases and pests affecting the FGR. Action, review existing standards of protocol where appropriate and when needed, appropriate voluntary protocol for the movement of plant material across the countries and region to avoid the spread of invasive organisms. Promote natural assessment of the invasive alien species and their effectiveness of FGR using regional or ecosystem approach. Work with the International Plant Protection Convention to include FGR in existing biosecurity regulation and integrated concern about the FGR. Promote the development of research on pests and diseases that affect the FGR. Uses of genetic resources. What are the uses? So, what does using genetic resources mean? Why genetic resources are useful? Using genetic resources, whether from plant, animal, microbes, refers to the process of researching their beneficial properties and using them to increase scientific knowledge and understanding or to develop commercial products. The rapid development of modern technology over the past decades has enabled us to use genetic resources in the way that have not only fundamentally altered our understanding of the living world, but also led to the development of new production practices that contribute to human well-being, ranging from vital medicine to methods that improve the security of our food supply. It also improved conservation methods that help safeguard global biodiversity. Genetic resource can be two type uses. One is commercial use, another non-commercial use. The commercial uses are specialized enzymes, enhanced genes, small molecules, crop protection, drug development, specialized chemicals in industrial processing, and also to insert genes into crops to obtain desirable traits. Non-commercial use, in non-commercial uses, genetic resources can be used to increase knowledge or understanding of the natural world with the activity ranging from taxonomic research to ecosystem analysis. This work is usually conducted by academic and public research institutions. The distinction between the commercial and non-commercial uses and the actors involved are not always clear-cut. Companies can cooperate with the public entities or commercial research, and sometimes research with no commercial intentions lead to a discovery that has commercial applications. Contribution of forest genetic resources. They contribute directly to the food security by providing fruit, resin, gums, and many other food products. Moreover, they support many animal species, pollinators, and indirectly play a key role in ensuring agriculture and food security. Now I will come to the CBD and Nagoya Protocol, how far we have come in India. The Convention on Biological Diversity, known as Biodiversity Convention, is multilateral treaty. This convention has three main goals: the conservation of biological diversity, the sustainable use of its components, and the fair and equitable sharing benefit arising from the genetic resources. This third one is very important from our present training program. The Convention on Biological Diversity, its objective is to develop national strategies for the convention on sustainable use of biological diversity, and it is often seen as the key document regarding the sustainable development. The convention was opened for signature at the Earth Summit in Rio de Janeiro on 5th June 1992 and entered into force 29 December 1993. It has two supplementary agreements. One is the Carthagena Protocol and Nagoya Protocol. India became the signatory of the Convention on Biological Diversity in 1994. The CBD is a multilateral treaty aimed at conserving biodiversity, its sustainable use, and ensuring fair and equitable sharing of the benefit obtained through the bioresources. 26 years of the several legislation later, India appears to have come a long way. While there are national laws in place to ensure the compliance with the CBD and nodal authorities to overcome this in economic and other benefits reaching the communities that share their biological diversity, associated tradition knowledge. Policies and legislation. After India rectified the CBD, there was no looking back. In 2002, India became one of the first countries to enact a law, the Biological Diversity Act, to implement the treaty within its borders. This act is decentralized for the implementation. The nodal biodiversity authority at the helm of the perform, facilitate, regulate, and advisory function to conserve genetic resources and ensure fair benefit sharing. As of today, there are SBBs in 29 states, and there are 244,727 BMCs and additional 4,371 BMCs in 2 union territories. Nagoya Protocol access benefit sharing is a 2010 supplementary agreement to the 1992 Convention on Biological Diversity. Its aim is the implementation of one of the three objectives of the CBD, the fair and equitable sharing of benefits arising out of the utilization of genetic resources, thereby contributing to the conservation and sustainable use of biodiversity. It sets out obligations for its contracting parties to take measures in relation to the access to genetic resources, benefit sharing, and compliance. The protocol was adopted on 29th October 2010 in Nagoya, Japan, and entered into force on 12th October 2014. As of October 20, it has been ratified by the 128 countries, which include 127 UN member states and European Union. In 2014, India became a signatory to the Nagoya Protocol of the CBD. This international agreement deals explicitly with ensuring the access benefit sharing, that benefits obtained from the use of genetic resources share as a fair and equitable way with indigenous knowledge. Indian legislation to rectify the protocol came in the form of ABS guidelines notified the ABS in 2014. These guidelines regulate the various aspects of benefit sharing. Indian National Forest Genetic Program in India. What are the initial efforts taken by the MOEF CCC towards the conservation of FGR? MOEF CC along with the ICFRE has organized a network in the countries known as the Forest Genetic Resources Management Network, FGRMN. A national level workshop was organized at the Institute of Forest Genetic Resource Tree Breeding, Coimbatore in 2011 to develop strategies for the FGRMN and also prioritize the important tree species for the FGRMN program. These activities were involved by various stakeholders like state forest departments, ICFRE institutions, state forest research institutes, and universities across the country. ICFRE has established a National Bureau of Forest Genetic Resources under the International Genetic Resources Program, along with the line of the National Bureau of Plant Genetic Resources. ICFRE is managing the collection, documentation, evaluation, and use of tree genetic resources available in India. ICFRE has established similar line action as established by the NBPGR, FAO, CREDA, DENIDA, DFSC, FRED, FORTIP, World Bank Project, and UNDP in promoting FGR research activities in India. ICFRE is interacting with the various international organizations such as the International Plant Genetic Resource Institute on specific issues related to FGR conservation. What are major activities of the FGRMN network? The major responsibility of the network is to plan, conduct, promote, coordinate in activities concerning exploration, collection, characterization, evaluation, domestication, conservation, sustainable utilization, exchange of germplasm, and plant quarantine. Are there nodal centers established under FGRMN for monitoring? What are their jurisdiction? At initial phase, 2 nodal centers have been established under the FGRMN for ensuring conservation, management, and utilization of the FGR in the country. IFGT will act as a southern nodal center. FRI, Dehradun, is the nodal center for the north and northeast regions. Is there any legal framework governing the FGR in India? At present, there is no specific legal framework controlling FGR. However, the legislation that governs biodiversity conservation, sustainable use and access and benefit sharing, Biological Diversity Act 2002, and the Protection of the Farmers' Right and Plant Varieties, Protection of Plant Varieties and Farmers' Right Act 2001 have implication on FGR. The collection of the FGR from the wild and their transport are regulated by the Indian Forest Act 1927, Wildlife Protection Act 1972, and various state forest acts. Thank you. This was my presentation.